As always, we've got our part file opened up. We're going to go ahead and switch from design to manufacture, and we're going to create our very first setup. So as you're seeing in most cases, my part here is actually ambidextrous, this kind of wheel hub or whatever this part may be. So we're going to set our X, Y, and Z position. I'm actually happy with this. We're going to work on the back side of this part first. We could go from here into our stock, of course. We can adjust out our stock. If you haven't seen this type of stuff, this is all things that I cover on other videos that you're more than welcome to go watch. So let's say our stock is actually closer to 4.5. I'm going to hold on to this back here by where this undercutting / shoulder is. So if I flip this part over, or I use a sub spindle for op2, we could actually just take that little bit off. So as always, I like to offset from front. In this case, I'm going to offset, let's go 50 thou on this one to clean up that front face. It is a little bigger diameter. Maybe our bandsaw doesn't cut the most perfect of cuts. But as you can see, we have our setup. I do like to look at this kind of in an XYZ fashion so that my tools come in on X back here. Makes my life a little easier. Another kind of neat trick here, as you've seen in my other videos, is we could do a section analysis. I did luck out where the origin of this part is very easily accessible to cut this part in half. I don't have to do anything crazy. But we could do a split profile as well, and maybe even look at this from a top-down view to get all those profiles in there. So very commonly, the first thing I always like to do is I like to do a facing cycle. And we're going to use default tools for the most part, unless we run into any issues. So I'm going to go with that CNMT right-handed tool. We're going to see that tool come in, face off our stock. Pretty standard here. If I wanted to do multiple passes, again, based on 50 versus 40, we're now making 2 cuts. We're going to go ahead and hit OK. From here, we're going to rough the outside of our part. As you guys are going to see, I'm a big fan of just kind of hitting OK a lot of times on my tool paths to get things done. So we're sticking with the same tool here. We can make this a little bigger. Hopefully my fat head down here at the bottom doesn't cover it up. But in the case of this part, again, working front to back, we're actually going to stop a little bit short, so let's go ahead and change our back location to a selected area. And I'm going to select this back face here. Another thing I want to do is I actually want to extend just a hair past that. Again, just makes it a little easier when we flip it over and do our machining the other way. So let's add a 1/8 inch onto this, 0.125. Moving over to my radii, outside in. Granted, the profile of our part is going to save us here. We're never actually going to make it all the way to this inner, because we are model aware, so we don't have to worry about anything there. Jumping into our passes tab, for some reason, I'm not a big fan of 40 thou step downs. Let's go 0.75 on this. It is an aluminum part. We could be a little more aggressive. Another thing I like is the even depths of cut. This will actually reduce this amount. It won't reduce the passes, but it will bump it down or up as needed. And always, we do have our stock to leave. So let's go ahead and hit OK and see what we get. So very first thing a lot of you are noticing, we're getting undercutting. I did make a video about undercutting the other day. We don't want undercutting because we're going to come in here with a grooving tool. So let's go ahead and turn off the actual allow radial grooving. So I'm not going to allow radial or axial grooving. And we're going to go ahead and hit OK again. And as you can see, we're coming down around our profile. We are extending past that actual flange / shoulder in the back. So everything is shaping up very good for this actual part. From here, I'm going to go ahead and just derive out to a turning profile finish. What this actually is going to do is keep things like our actual tangential extension, our back reference points, things like that. So let's go ahead and instead of going 0.25 or 125 past, let's go 0.75. Again, I really don't need to adjust much more here. We could actually just hit OK. And just like that, we're coming in, chasing that profile. We are stopping short here so that we're not hitting the stock or having to cause any lead out issues. So we still are plenty past for when we flip this part over. We don't have to worry about anything here. So now most of you are watching this video probably more concerned about getting in here and grooving out the inside of this area. So let's jump over to the actual grooving toolpath. So one neat thing that we do have inside of Fusion 360 is we do have turning groove. Again, this is a single or multiple kind of grooving situation. If we were doing a grooving roughing kind of with the finish all rolled into one, we have a single groove method if you're cutting like snap rings or like In most cases, like O-ring grooves, you could just single hit it. We're going to start with turning groove. And what turning groove is going to allow us to do is go out and pick our grooving tool. So I'm going to go out to the Fusion 360 library. I'm going to grab the OD grooving tool right here, which I'm actually going to go for the one right below it. And if you guys didn't know, this new tool profiler, you could actually grab and move things around. I am using the shift key to slide that tool up and down. So depending on your keyboard cutout or your shortcuts could be a little different. But as you can see here, we have a nice little lollipop kind of style tool. And that's what I'm going for, because we're going to do things a little different with the same tool to evaluate a couple different ways to do this. So we do have rest machining. We're going to turn that on so that it doesn't mess with any of these areas that have already been cut. Again, I can actually say I don't want to go all the way to the model back. I'm going to go ahead and do that selection move again. We're going to go ahead and rotate around and grab that flange face. And moving a little further on, we have our passes tab. So we do have an up and down only. Again, up only if you're trying to back drag a lot. What is your step over? All of this is customizable, guys. We're just going to go ahead and allow this to do what it naturally does based on its settings to confirm that we're actually getting the path on the part and in the right area that we want to work within. So as you're seeing, as we are coming out of this, again, that point is always referencing the farthest left side of the tool. So we do come in, we are cleaning up this upper face, dropping down into our groove, coming back out, and we're doing this in a vertical fashion. So if we were to simulate this, apologize there, we would hit the tool button, not the actual simulate button. And I'm going to slow this down because usually it comes out way too hot and heavy. There we go. We're doing that roughing cycle. Again, it's kind of just looping in and out. Every time it's backing off, fully retracting, and then going back in with a fresh cut. Always using the front side of our tool. Again, roughing into several different finishing strategies. However, we do have a problem here where we're back dragging, and because of the relief of that actual lollipop, we're causing a collision. So let's fix that, and let's just get a good tool path. So we're going to go back to our passes tab. We're going to go down. We're going to say we only want to do down. Again, we can go ahead and hit OK. Give it a sec to generate, and then I'm going to right-click and go into simulate this time. Little different way to get here, still get us the same results. So while this is running, we're going to zoom in just a hair. Again, we're always going down. And the key element of this is when we get to the point of actually doing this backside area here, I'm going to click the point. It's going to recalculate. But if I forward drag my mouse, so I'm clicking and dragging, you notice how this path is coming in, down, and all the way to the center of the lowest point. So it's getting all the way down here. Again, it's only feeding inwards towards my diameter. We no longer have to worry about the relief of that tool. So let's look at another way to do this. So another way we could do this is we could actually go in, and there is now turning adaptive rough. And what turning adaptive rough is going to do is it's going to make a much more organic kind of profile. So what you're seeing me do is I'm actually picking things very quickly here so that you guys can see this. But again, based on our optimal load, whatever we set that to, we're going to go ahead and hit OK. And one issue we're going to run into is we didn't turn on rest machining, but this does give you a good mental idea of what's happening. So just like adaptive clearing in the milling environment, we're making kind of an arcier, much more point-driven kind of strategy here. Does it necessarily mean it's faster? Sometimes it is. Again, because we're only cutting one direction here, we could actually cut more bi-directionally with a tool like a lollipop, again, dropping our cycle time. So what I'm going to do is we do have that 4 minutes and 17 seconds. I'm actually going to go in and protect that because we don't want to regenerate as is. I'm going to go back to my other tool path, which is the adaptive. Let's turn on our rest machining. We're going to go ahead and hit OK. We are going to get an error, and that's because we're out of order, and that part of our model is actually already complete. So with a little drag and drop and a Control-G to regenerate, there's my rest machining coming in. There's my tool path going about what it needs to do. But what you're seeing here is by comparison, and let's get this just a little closer. So we're actually doing a 40 thou step over on the traditional grooving kind of tool path. So let's go back to our adaptive clearing, and let's say we're going to do no more than a 40 thou optimal load. So now that we're doing a 40 thou across both tool paths, we can get a little more accurate time study to see, is there a bigger part of this? Is there a smaller part of this? Like, is one tool path faster than the other? Well, initially it seems like it, but keep in mind, let me expand this out for everybody. Our initial grooving, which is just a OD grooving kind of traditional approach, also has finishing passes in it. And if I go into adaptive roughing here, is you're going to notice is I don't actually have a finish pass. So I do have finish allowance, which is very comparable to kind of like a stock to leave scenario. So you could turn off finish allowance. However, is when we simulate this tool path, let's make sure that we're doing a full finish pass at the end of this. So again, we're going to speed this up just a little bit so we can get down into our part. And as you're seeing is, let's go ahead and pause this and zoom in a little bit. This is that finish allowance, or stock to leave, as a lot of us were much more familiar with. But as we let this cycle actually run down, we're going to notice that it does come back and it does do some cleanup. Again, just the way the adaptive clearing works, it's now coming back and pecking out those corners and then doing our full retract to get up and away from our part. So we still have material there. So you want to keep that in mind, because this is why we now have what's called a turning groove finish strategy. So what I'm going to do is I'm actually going to do another derive, and we're going to go through and we're going to do a turning groove. And what we want is we actually want turning groove finishing. So again, based on our geometry and our selected point, we don't want to go past the back of our part. This is why I'm doing a derive. As you're seeing in my passes tab, we have a front to back. We also have a back to front or both ways. And again, we could go through and we could set a number of step overs. And what are those step overs? Keeping the number one, it will only do a single pass. Don't worry, guys. And we do have, machine single grooves turned on. We don't have any single grooves. Again, those snap ring grooves or O-ring kind of grooves. But as you can see, we went ahead and created that actual tool path, and we are getting an error. So let's investigate that error. So what it's telling me is an empty tool path. Now, it could be telling me an empty tool path for a lot of reasons. And some of those reasons can be attributed to the front to back. We have the avoid upwards cutting, things like actually doing our model front. It can be getting interference from the idea of what's already been finished. And now thinking about it, the real problem that we have, and even the best of us makes this mistake, rest machining is one of the best things you can use in actual CAM environment of Fusion, but it also can cause nothing but problems. So let's go ahead and redrag this up above the cycle with the finishing path. Again, we're going to use Control-G here to regenerate. And just like that, now it is automatically picked up on the fact that it needs to only go inside this groove to clean up everything and anything. So even the best of us guys, completely understandable that it happens to all of us. However, if you were struggling with this on your end and you want me to tell you that you made this exact same mistake, you do have a link down below to put in support tickets to yours truly to help you out. So what I'm actually going to do for all of us is we're going to go ahead and delete this actual cycle out of here. So I'm going to go ahead and delete that so we don't keep running into those problems. Again, we were at about 4 minutes. This is claiming, 2.5 plus 8. Very, very beneficial depending on what you're doing. I'm going to go ahead and simulate this from the top. So let's square back up to this. And let's see if we get any collisions or any problems based on our current tooling and creating those profiles on this part. So we actually check all good. No red crashes, no stop on collisions that are happening. I'm actually extremely happy with that so far. So from here, we could actually program the backside of our part. We could do our drilling cycle through our part. However, I am going to throw a little kink in the system. Let's look at one additional way to actually do that inside groove. So for most of you, you may not know this, but we can actually do a turning profile rough with a grooving tool. And again, I should have did this as a derive. Big mistake, right? Can't always be perfect. We also want our rest machining turned on, so we got to keep that in mind. And then based on our 40 thou maximum depth of cut, we're going to go ahead and hit OK. We are going to get alarmed out here because, as you can see, we're going to the back of our part when we need to go a little more than that. So we're just going to drag this guy up and drop it, allowing me to regenerate. Again, this is always tricky when you're trying to do comparison. So what you guys are now starting to see is the fact that we're going back and forth in a horizontal kind of a traditional OD roughing strategy, but we're doing this with a grooving tool. So again, you always want to make sure your grooving tool is capable of this, but again, you could actually use just normal roughing to rough out the inside of this area, the same as we did with adaptive clearing or the traditional grooving toolpath, and then come in with our finishing cycle. You could also still use a y-axis approach, or an x-axis approach, I should say, kind of groove out and finish cycle all in one. So there's never really a perfect answer to these situations. It's always going to be different on a case-by-case scenario. Knowing that this part has a actual fillet inside of your radius, this is also a big thing as well. So again, maybe the traditional way would have worked very, very well. Another thing I can do is, because of rust machining, we can go through and actually set that up. So I'm not going to spend any time with the rust machining. I am very happy with what's here. Maybe my customer has given me allowance inside. So let's just go ahead and jump a little further on, and let's flip our part over and machine the backside. So I'm going to create a brand new setup. I'm going to flip my Z-axis. I'm going to do one of my favorite things, which is use preceding stock on this. And we're going to say continuous rust machining, which is going to give us that nice and lovely little hat upon simulating from the backside. So from here, we're going to go in, and I'm actually going to use the move of the old copy and paste. So if you guys didn't know this, because we selected a certain depth on our part, we can go through and steal anything and everything going back the other way. And let's go ahead and copy this. I'm going to go down to my setup 2 now and click and right click paste. And what's going to happen is anything and everything that we defined here is going to come back the opposite direction in my part. So we did do certain things that were stopping at certain locations. Again, our facing cycle, because we have a certain step over put in, automatically recognizing my stock versus my model. Even moving down a little bit further to roughing out that actual pocket. But we could get this even better here. And how I'm going to get that better is I'm going to go ahead and go in, and I'm going to do what a lot of you may or may not know is turn on rust machining once again, allowing it to now recognize where there is and where there isn't stock based on my part profile. Again, we look at that finish cycle. There is no rust machining turned on. However, it's actually going in and cleaning that up exceptionally well. So that wraps up another Turning Tuesday. As always, guys, it's a great time for me over here to be able to make this content for you. However, I would love to hear from all of you on whether or not you like this content by either hitting the like button, adding comments down below, subscribing to my channel, or even sending me an email through the support channel to fix your toolpaths or kind of express to you different ways to do what you're doing. That said, like always, go ahead and have a great rest of your day.